All right, so let's do 4.5. So in the last lessons, we've been factoring, right? And one of the patterns that we have been using is if you have a perfect square trinomial, right? So here is my perfect square trinomial, and basically the way we recognize it is if you have a perfect square, right, a square and b square, and then the middle term is 2ab, and it factors, very nicely as a plus b squared, right? So we have to have a perfect square in order for it to, factor nicely like this. But this term, right, is 2 times a times b. So wouldn't it be great if all quadratic functions were perfect square trinomials? I mean, factoring would be so easy, right? Well, it turns out that's actually a possibility, to make everything a perfect square trinomial, right? But what is the benefit? Let's just see exactly what the benefit is. Why don't we try to solve these using the square root property. So notice here, this is a perfect square trinomial, right? So I factor this and I get x minus 6 squared equal to 25, okay? So now I can take a square root of both sides. So then I have x minus 6 equal to what? Plus or minus 5. Now I take the 6 over to the other side, so x is equal to 6 plus or minus 5. That means x is 6 minus 5, which is 1, and 6 plus 5, which is 11.
You can't just
right?
write it like that.
Right. It has to be completely simplified. Okay. Where's the notes? Okay. All right. So why don't you, just so you don't miss much, take this and review up paper and then you can transfer them. Okay. All right. So let's take a look at this next one. Ooh, another perfect square trinomial. I'm going to factor this as x minus 8 squared equal to 49, right? Take a square root. Take a square root. X minus 8 equals plus or minus 7. So x is 8 plus or minus 7, which means x is 8 minus 7, 1, and then 8 plus 7, 15. Okay. What about this one? So we're going to factor it as x plus 4 squared equals 20. Take a square root of both sides. X plus 4 is how much? Plus or minus 2 root 5. You've got to separate. You've got to simplify. And then, so x is negative 4 plus or minus 2 root 5. So again, we have two solutions. Negative 4 minus 2 root 5. Negative 4 plus 2 root 5. So what we're seeing is these two had solutions, like this one had solution 1 and 11, 1 and 15. So A and B had solutions which are rational, right? This one, it has a 2 root 5 in there. That's an irrational number. So this has two irrational solutions, all right?
Wait, so if it's a radical, it's okay to leave the plus or minus?
Yes. Right, because this is the most simplified. The thing is, you have to get it to the most simplified form, okay? So let's take a look at this one. It's going to be x minus 3 squared is equal to 32. Take a square root. So x minus 3 is how much? Plus or minus 4 root 2. Take the 3 over to the other side. X is 3 plus or minus 4 root 2. Right? Isn't that beautiful? Look at how graceful it is to to solve that. Isn't that just like, right? It totally is. Well, that's the question, right? Wouldn't it be great if all quadratic functions could be factored like this, right? So now, it would be so cool. So cool. But, like, don't fret, because there is a way. We can make every single polynomial, every single quadratic function into a perfect square trinomial. How exciting is that? Oh my God. Yes, so exciting. We call that completing the square, because, get it? You complete it and you make it into a perfect square trinomial. You complete the square. Yeah.
What if the perfect square equation equals a negative?
Oh, well, now you're fast forwarding a little too much. So hang on there. Hang on. Don't steal my thunder. Hang on. Okay. All right. So here's how we complete the square, right? So we know we have A, B, and C coefficients, right? We want to find the value of C that will make the expression a perfect square trinomial. So here's what we do. You first find half of B, or B over 2. Then you square it. So C is B over 2 squared. Okay, so take B, divide by 2, and square. So take a look here. Find the value of C that makes each of this a perfect square trinomial. This is B. It's 14. Okay, yeah, I get it. It's negative 14. I divide by 2, and then I have to square it, right? So negative 14 divided by 2 is 7. Square it, I get 49. Because I'm always going to be squaring, sometimes I kind of do ignore that negative, if B is a negative, right? So moving along, so that's C. Here, B is 18. I'm going to take 18, divide by 2, I get 9. Square it, C is 81. Okay? All right. So let's go ahead and do that. So we're going to solve quadratic equations by completing the square. This is for the case that A is equal to 1. All right, so what we do first is move the constant to the other side. Find C, and we're going to add it to both sides of the equation. Factor the trinomial, and then solve by the square root property. Okay, so let's do this. First thing is I take the 24 over to the other side. So take a look at what I do. X squared minus 10x plus a number equals negative 24 plus a number. Okay? So you see what I did? All I did is I took the 24 over to the other side, but now I have to insert another number there.
Can we just write C, like plus C?
Well, this is going to be faster because we're just going to put the number in there now. Yeah.
It's the same number.
Okay, hang on. Yeah. Okay. So now, remember we have to complete the square. Remember we have to balance the equation. So you can't just add something to one side and not add it to the other side. So now, what number goes there? Take the 10, divide by 2, squared. So that's 25, 25. Right? Now, magically, that's a perfect square trinomial. I factor it. X minus 5 squared is equal to 1. Take a square root. X minus 5 is plus or minus 1. X is 5 plus or minus 1. So X is 4 and X is 6. Right? Isn't that super cool? So let's do it again. Let's factor. All right. Bring the 25 over to the other side. So I say x squared plus 12x plus a number equals negative 25 plus a number. So what number goes there?
36.
Okay. So I get x plus 6 squared equals to how much? 11. Take a square root. X plus 6 is plus or minus root 11. So x is negative 6 plus or minus root 11. So satisfying, right? Okay. Take the 2 over to the other side. x squared plus 2x plus a number is negative 2 plus a number. What number is going to go there? 1. So here we get x plus 1 squared is equal to minus 1. That's what you were asking. Yes. Take a square root. So x plus 1 equals how much? Plus or minus I. And so now I get x equals negative 1 plus or minus I, right? So now this is the third variety. We got some with real rational solutions. We got some with irrational solutions. And now you can also get some with complex solutions. Isn't that cool? Yes, yay. Okay, I love this stuff. Okay, so here we go. X squared plus 4x plus a number equals negative 11 plus a number. Right? What's the number? 4. 4 sounds good. X plus 2 squared equals negative 7. X plus 2 equals, so now you take a square root, plus or minus I root 7. This is why we learned about the i's. Okay, so x is negative 2 plus or minus I root 7. So beautiful. By the way, when I graph C and D, what is it going to look like? I mean, it's going to look like a parabola, but where is it going to be situated? Does it face down?
No.
Up, because the A's are positive. So how's it going to look? Is it going to cross the x-axis?
Yeah.
No, there are no real zeros, so it's going to, just be floating, right? Somewhere over there, right? Because it doesn't have any real solutions. That means no x-intercepts. But there are numbers that when you plug them into the equation, they give you 0. They just happen to be imaginary numbers. It's okay. Okay. Now, this was the case when A is equal to 1. But we know life is never perfect. What if A is not equal to 1? Well, you just have to make it equal to 1. Okay? So if A is not equal to 1, you have to divide by A first and then do everything. So here, I divide everything by 3.
That's not fair. What if you just multiply it, it'll be...
Nope. You can't make up math as you go along. We got to follow the rules. Okay, so x squared plus 10 over 3x plus a number equals 8 over 3 plus a number. Okay, so now I'm going to take 10 over 3, divide it by 2. Dividing by 2 is the same as multiplying by 1 over 2. And then I need to square it. So that becomes 10 over what? I'm sorry, 5 over 3 squared. Correct. 25 over 9. 25 over 9. Oh boy, fractions, don't we love them?
No.
So, x plus, you got to take the square. The square root, right? So it's 5 over 3. And now check, if you multiply 2 times this times x, do you get 10 over 3x? Oh my God, you do, right? Because you worked backwards and you made it that way. Okay, what about the other one? How much are we going to get?
49 over 9.
49 over 9. Oh my God, how simple is that going to be now? Isn't that cool, the way it worked out? X plus 5 over 3 is equal to plus or minus 7 over 3. Oh my God, how satisfying is this now? So negative 5 over 3 plus or minus 7 over 3. So x is negative 8 over 3 and 2 over 3. Right? Look at that. Look at how cool that is. Oh, sorry. It's negative 4, negative 4. Negative 4. Huh? It's negative 4. Negative 5 minus 7 is negative 12. Okay, moving along. So, okay, all of these that have rational solutions, they could have also been factored, right, from the beginning. However, today we're learning completing the square, and we have to learn it, in order to factor the ones that can't be, in order to solve the ones that can't be factored. So divide everything by 2 on both sides. So here we get x squared minus 3 over 2, x plus a number equals 3 over 2 plus a number. What's the number that goes there? 9 over 16. So x minus square root of this is 3 over 4 squared is equal to, so if you multiply that by 8, 24 plus 9, 33 over 16. Okay, oh no. Take a square root. No, it's not. X minus, oh my God, don't say that. X minus 3 over 4 is equal to, take a look, plus or minus. Let's split that up. Root 33 over root 16, which is 4, right? So now x equals 3 over 4 plus or minus root 33 over 4. Okay, this is rational, but it is a real number, right? So I can also write it as x equals, in one fraction, 3 plus or minus root 33 over 4. Right, that definitely, that is amazing, right? Just amazing. Okay.